Hello, my name is Grant Fritchie. I work for Redgate Software. Hey, you know what? I get questions a lot, especially when I'm doing the all-day seminars. We're just doing stuff all day long. There's a lot going on, and I am not even remotely afraid to say I don't know to questions. For example, I was teaching about adaptive joins, one of the new join type inside of SQL Server, Azure SQL Database, and SQL Server 2017. And the question came up, what happens with the whole thing with adaptive joins if you have a join hint? And I'm like, I don't know. Let's find out. Okay, so what we have here is got a very simple query. It's just aggregating a few columns and doing a group by. Let's go ahead and run this query and let's take a look at the execution plan. So the query comes back, it returns a few rows. The execution plan is a couple of index scans, a hash match aggregate for the group by and the aggregations, scalar, and then another hash match, and in it goes. Now that's a normal query without a column store index involved. So let's scroll down the page here a little bit, and we've got a script that will allow us to create a column store index. So let's go ahead and do that. And maybe this table is a little small for a column store index, but we're not really worried about that. We just want to see behavior today. So let's take a look at the same query again and take a look at the execution plan again. We're going to execute the query, get the actual plan so we can do estimates and all that fun stuff. So now we see it's doing a column index scan, column store index scan with a hash match, again a compute scalar operator, and then we see the adaptive join. And the adaptive join works on the principle that if the adaptive row threshold is exceeded, it will then do a hash join down this path. If the adaptive row threshold is not exceeded, it will do a loops join down this path. And you can see that, yes, these add up to more than 100, but it's because it's two different paths to the data. It's not like the old bugs that we used to get with the multi-statement table values or defined functions. So in other words, this is an adaptive join, a normal operation. So what happens if we put in a query hint? Well, let's do an inner hash join. Basically, exact same query, except we had to throw in the inner word in order to use the hash join. And so let's execute that. And then we get back, and what it's done is it's done the hash match join again from the column store index scan, and then a hash match aggregate. So you can see that the hint has allowed us to take control of the query and do things the way we want to. But the question is, yeah, it changed the plan. The question is, did it change the performance? Well, let's check it out. So here's what we're going to do. Let's do go 100, so we execute it 100 times. And the same thing down here. Whoops, never type in demos. Go 100, there we go. And let's make sure that we've got the live data set up. Let's go ahead and clear it. So we've got a clean data set we're bringing in. And we're going to run this query 100 times, just so we get any kind of vagaries or weirdness. Oh, and we're going to turn off execution plans. Any kind of vagaries, weirdness, blocking, locking, additional monitoring, or system sunspots, anything that might interfere and change the behaviors, it's probably not going to change it very much over 100 executions. So we're going to execute it 100 times just so we get the distribution and we can do the average duration and the average reads over that 100 executions. Okay, great. Now that's done. Now we're going to run it again with the query hint in place, and we'll run that one 100 times. Now it'll take just a second or two, not very long, 10 or 15 seconds. And the whole idea here is just to eliminate, the idea of running something one time. The very smallest little thing could interfere with it. Running it twice still might see interference, but running it 100 times over a period of time, pretty good chance that you get a decent average on the behavior. Okay, so that's all done. Let's go to our live data. Let's stop the feed. There it goes. Let's group the feed by batch text so we can definitely see each query grouped together. We got the hint query where it has the hint right at the top, and then we have the unhinted query down below. Cool. Now, let's add some aggregations. Let's take a look at the average duration, and let's take a look at the average reads. And with that in place, we see that the unhinted query had about 70 reads. The hinted query had about 70 reads. So from a read standpoint, they're doing about the same amount of work. But the difference here is 168 milliseconds versus 221 milliseconds on average. That's fairly radical differences. So what's going on? Why are they so different? Clearly, throwing that hash join, yeah, we got a hash join in and we got to be able to control it, but it didn't improve performance. So what happened? Well, let's do this. Let's get both queries, the execution plans on both queries back on the screen. Put these in, turn the execution plan on, and then take a look at what happened. Now we can move these together. There we go. Now both are obviously accessing the column store index to scan. That makes sense. Both are doing joins. Both are doing hash match aggregates. But the differences are interesting. The differences are right here. If we take a look at this column store index scan and then take a look over here at the properties, we see this particular property. Actual number of locally aggregated rows, and it's 113,443. Locally aggregated rows, yeah, this is what's called a pushdown aggregation. It's an aggregation occurring inside the cluster, the column store index scan itself. And if you look, the output, the actual number of rows processed by this thing are 0, which makes no sense. And if you look over here, we can even see in the tooltip, estimated 113,000 rows, actual 0, and you think, my gosh, what's going on with this? But if we look at here, it estimated 441 rows, it's actually 441 rows. What's happened here is that the hash match is being done inside here. So even though this scan plus this scan, because it is 400 rows, which is beyond the row threshold, so this is doing a hash join. So these things are roughly the same. The amount of reads are roughly the same between these. The processing of doing the aggregation as it scans versus doing the aggregation as a second step makes for a much faster query. So yeah, we can control it with the hint, but that doesn't mean we're going to get what we want out of it. There's fully the optimizer, when you do a hint, you've taken away the optimizer's choices, and therefore the optimizer can't do the pushdown aggregate in this case. It has to do that hash match first, and we don't get any performance enhancements from forcing that hint in this case. So in other words, a join hint is a commandment. It tells the optimizer what to do. It forces it to do one thing, and it did the one thing that we forced it to do. And so you can put a join hint and force it in one direction if you want to. It could affect performance, as we saw, but you're free to do anything you want in there. Have fun. Anyway, that's it. My name is Grant Fritchie. I work for Redgate Software. Please, please, please hit that subscribe button down below. Thanks a lot. Talk to you later.